So I told you in the last lesson that I will teach some numerical methods, which is basically solving equations. Of course, I could have taught you Descartes' rule of signs. Just, I don't know whether, I think it is in, it used to be in the old AEB syllabus, which is now these days, I think, AQA. I used to teach that when it was AEB. And it used to be in the old Cambridge syllabus as well. But I've not come across that in even when I taught the Edexcel before. I'm talking of 80s. Yeah, no. Doesn't matter. So, toward the end, maybe I might teach you that just out of interest. I don't know. We shall see. Today I want to teach you iteration, but before I start the concept of iteration, what I'm going to talk to you today was a method used. Remember, we go back 3000 BC. Is it 3000 BC? Yeah, the Babylonians. The Babylonians had used the method which I'm going to show you today to calculate square roots. Of course, they didn't have all the formula or anything, but they had a concept. You see, the mathematicians then had a concept how to find the square root. For example, they say you want to find an approximation. Oh, these pens don't write. Find an approximation to square root of 20. Okay. It's not a perfect square. So you have to find an approximation. So then, you know, if you write the square numbers, 20 is somewhere in between. So you know it's between 4 and 5. Yeah. It can't be 25. It can't be 5 because 5 squared is 25. So we start with, let's say, let x be approximately equal to root 20. Yeah. X will be approximately equal to root 20, and we assume x is approximately 4. We know it's less than 5, so we take it as 4. Is the very first approximation. Now what I do is, but you realize that 20 over x is, if x were to be equal to root 20, what would be 20 over x? Root 20, isn't it? So, if x equals root 20, then 20 over x is root 20. But we know x is not exactly equal to root 20 because there is no exact value. Whereas, if x is less than root 20, what will happen? If x is less than root 20, then this is less than root 20. So you're dividing 20 by, look, this is actually root 20 times root 20 over x. This x is less than that root 20, so this is more than 1. So the answer you get is going to be more than root 20. If this x, suppose instead of 4, someone says, oh, why can't I start with 5? Okay. If x is more than root 20, say x is 5, then this is more than root 20, that ratio will be less than 1, so your final answer will be less than root 20. So what they did was, okay, we know the approximation 20 over x, right, is root 20. So therefore, what is the average of x and root 20 over x? Because remember, this x is an approximation root 20, and that's an approximation. What's the average? The average will be x plus 20 over x Average is half. So let's do it. I'm taking 4, yeah? So it is half of 4 plus 5, which is 4.5. So if 4 is an approximation to square root of 20, 4.5 is a better approximation. Why? Let's look at what is square of 4.5. Just to confirm. So 4.5 square is 20.25. So 4 squared is 16. So 20.25 is nearer to 20 than 4. Root 20. 4.5 is nearer to root 20 than 4 because one is 16, one is 20.25. So therefore, if I were to call x1 as 4, x2 is a half of x1 plus 20 over x1. Okay. Now I know, take the average of x2 and 20 over x2. Because remember, x2 is also 20 over x2 is also approximately root 20. So what does it come to? So that is half of 4.5 plus 20 over 4.5. Let's find the answer. Pretty interesting. Of course, you don't have to know this, by the way. So it is 20 divided by 4.5 equal to plus 20 equal to divided by 2. There's something wrong here. I'm not wearing my glasses. It is 20 divided by 4.5 is that, plus 4.5 is that, divided by 2 is 4.472. Let's call that as x3. So x3 is half of x2 plus 20 over x2. It is 4.472. This is 4.5. What is 4.472 squared? Let's take it to 3 different places. So 4.472 square is 19.998. Very close to 20. It's a better value because remember, this one was 20.25 when you squared. This one is 19. In other words, if you have 20 there, this is the exact value of root 20. I started with one value, then I came to the other value, then I came to this value. If I use it, I'll come there. If I use it, I'll come there. If I use it, I'll come there. In other words, as long as I keep on taking the averages and going down, I'll get better and better and better approximations to root 20. That is the method of iteration. That means you start with an initial value, use the initial value to find the next value in a formula, then use the next value in the same formula to find the next value, use a value in the same formula. So you keep on using the same formula over and over again to get better and better approximations. That is the method of iteration. And can you imagine, even though they didn't specify because algebra was not known those days, the Babylonians used this method, mathematicians used this method to estimate the square root because they didn't have printing. They didn't have, root square root tables. Of course, they definitely didn't have a calculator. Yeah? So that is the method of iteration. But it's not always only for square root. It can be used for anything, as I will show you in the next stage. I want to check the clock. Whether I have time. 10 minutes. So yeah, for example, let's say I had, let's take a simple quadratic equation, x squared minus 4x plus 1 equal to 0. Yeah, when x is 0 it is 1, when x is 2, when x is 1 it is negative, so it's between 0 and 1. When x is 2 it's positive. I think there is a negative. So when x is 2 it is negative. When x is 3 squared is 9, 10, positive. So between 2 and 3. Yeah. Now, can I rewrite this as x squared equal to 4x plus minus 1, x equal to square root of 4x minus 1? In other words, I will draw the graph of y equal to root of 4x minus 1. Anyway, let's confirm. X is 2, f of x is 2 squared is 4, 4 plus 1, 5 is negative. X is 3, f of x is 3 squared is 9 plus 1, 10, 10 minus 12 is negative. F of 4 is positive, so it's between 3 and 4. Okay, so I know it's between 3 and 4. So I will take the graph only between 3 and 4. So look, how do you find a solution to an equation graphically? You sketch the curves and find where they intersect. Now, do you agree? One curve is y equal to x, intersection, another curve is y equal to root of 4x minus 1. So y equal to x, this point is 3, 3, that point is 4, 4. So that would be the line y equal to x. And when x is 3, what is root of 4x minus 1? 4 3s are 12. When x is 3, root of 4x minus 1. 4 3s are 12. 12 minus 1 is 11. So square root 11 is 3.31. When x is 3, it is 3.31, somewhere there. Let's say 3.2. 4 times 3.2, 4 times 3.2 minus 1 is that square root of square root of, open the bracket, 4 times 3.2 minus 1, close bracket, equal to 3.44. So 3.2, 3.44. So if I draw that graph, somewhere there it goes like that. So do you agree that is where the exact root is? Yeah. I know it's between 3 and 4. I've used the graphical method. Now, this is the actual root, okay? Let's assume this is x1, an approximate root, okay? So do you agree? Can I call this as x equal to f of x? So x2 equals f of x1, yeah? So therefore, do you agree that is f of x1? If I draw the parallel, do you realize that this is also f of x1? So do you agree that is x2, which is f of x1? Now, this one will be f of x2. If I draw a parallel, I'll come to x3. If I assume that is f of x3, draw a parallel, x4. So what's happening? When I am using the same formula, x2 equals f of x1, x3 equals f of x2, x4 equals f of x3, I am using the same formula. Whatever answer I get in the previous application, I'm putting it in the next application. Then I'm using an iteration, and you see this iteration, you're coming closer and closer and closer and closer to the root. Yeah? That is the method of iteration. So in other words, to solve an equation f of x equal to 0, the first thing you do is locate the root between a and a plus 1. Okay, sometimes a and a plus 0.5. Then rearrange the equation in the form x equal to something. Having rearranged it, take a starting value, say the midpoint of the interval, put it into the rearranged equation, find the next value. Maybe 3.5 as we did. The first value may be 3.2. Yeah. Then I take the value 3.2, again put it in the same equation, get the next value, and the values will come closer to the root. Then we say it's a convergent iteration because it gives you the answer. But then, is it always the same? I do not know. Suppose instead I take, let me use a different color. I hope I have a different color. Yes, there is a green. Okay. Suppose I take x naught to be that, y naught to be that instead of, let's call it x naught. Now, do you agree? This is f of x naught. Interesting. Yeah? This will be f of x naught. No, that is f of x naught. If I were to draw a line parallel, I get x1. Then you see, that is f of, oh no, this is f of, sorry. This is f of x naught because that's the curve. And then, if I were to draw a parallel, that is x1. If I were to draw a parallel, that is x2. In other words, whether I take, this is unidirectional convergence. If you take a value less than the root, it converges upwards to the root. If you take a value more than the root, it converges downwards. In other words, the values step by step keep coming down towards the root. Something like, you got someone there and you are trying to catch coming down the stair and he is trying to catch coming up the stair, making sure he doesn't see you. Remember, catch, I don't know whether you played catching somebody on a staircase and without him or her seeing you. That's exactly what is happening. So, an iteration is nothing but repeated application of the same formula to arrive at an approximate. Remember, it is never an exact root. It's only an approximation to the root of an equation f of x equal to 0. Obviously, you won't use iteration if it's an exact root because you can find by other methods. Only when you can't find by other methods you use this. I want to see the time before I conclude because this keeps closing. Before I conclude because it's 18 minutes. Right. But at times it's not always convergent as I will show you here. I'll just spend 2 more minutes. Please bear with me. The same equation, remember, I could also write this as 4x equal to x squared plus 1. So, x equal to quarter of x squared plus 1. So, again the interval 3 to 4. The line y equal to x is there. When x is 3, it's 1. So, and when x is 3.5, I'll have to use the calculator again. I think I'll do it in the next lesson because let's leave it here. I'll start the next lesson with this to show you, okay? So that I don't have to write the question in the graph again. Alright? I'll see you in the next lesson. As I said, you don't have to worry in case you find this a bit too complicated. You have to know the method. But it's my job as a teacher to see if you can learn to understand why a particular method is derived the way it has been derived, okay? See you in the next lesson. Bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.